Good day, ma'am. This is Lian Joseph Tambes from BSOA 4B, and this is my report about Francis Turbine. So, what is Francis Turbine? The Francis Turbine was the first modern hydropower turbine and was invented by British-American engineer James Francis in 1849. A Francis turbine is a type of reaction turbine used most frequently in medium or large-scale hydroelectric plants. These turbines can be used for heads as low as 2 meters and as high as 300 meters additionally. These turbines are beneficial as they work equally well when positioned horizontally as they do when they are oriented vertically. Francis turbines are the most frequently used turbines for hydropower plants. So, Francis turbine is a reaction turbine, which means that working fluid changes pressure as it moves through the turbine, giving up its energy. The turbine is located between the high pressure water source and the low pressure water exit, usually at the base of the dam. A water moves through the runner, its spinning radius decreases, further acting on the runner for an analogy. The water flow entering a turbine impeller where the hydraulic energy of the fluid is converted into mechanical energy via shaft, which is then connected to a generator. The generator converts the mechanical energy into electrical energy, which can be used to power the equipment in the plant. So the parts of a Francis turbine. First is the water inlet, the head cover, the guide vane, draft tube, runner, stay ring, guide vane, spiral case, water guiding device. So these are the major components of the Francis turbine. First is the spiral casing. The spiral casing serves as the inlet for water into turbine, allow high pressure water from the reservoir or dam to pass through. To ensure efficient striking of the turbine blades, the water circular movement is controlled by gradually reducing the casing diameter, maintaining uniform pressure and the momentum of the for striking the runner blades effectively. So when the water enters the spiral casing from one end and exits circumferentially along the radial direction toward the runner. Spiral casing provides even distribution of kinetic energy and pressure energy so as to achieve required action for better performance for runner. To distribute the function of the spiral casing is to distribute water as evenly as possible to the stay and guide vanes and then to the turbine runner. So second is the stay vanes. Stationary stay vanes and guide vanes work in tandem to guide the water flow towards the runner blades. Stay vanes prevent radial flow, induce swirling, improving the turbine's efficiency. So next is the guide vanes. The guide vanes are the adjustable guide vanes play a vital role in controlling the angle of water striking the turbine blades, optimizing of efficiency. They also regulate the flow rate of water into the runner blades, allowing the turbine's power output to be adjusted based on the load. So the work of guide vanes are direct the water tangentially to the turbine wheel, known as a runner. This radial flow acts on the runner's vanes, causing the runner to spin. The guide vanes or wicket gate may be adjustable to allow efficient turbine operation for a range of water flow conditions. To regulate to regulate airflow and pressure that enters centrifugal compressor's first stage of compression. That is the function of guide vanes. And fourth is the runner blades. Fourth is the runner blades. The design of the runner blades directly impacts the turbine's performance and efficiency. In a Francis turbines, the runner blades are divided into two parts. The lower half is shaped like small buckets, utilizing impulse action for rotation, and the upper part utilizing a part utilizing the reaction force of the water flow. The combination of these forces facilitates the rotation of the runner. So running blades are prosthetic lower limbs. So a runner is placed directly in the water stream, allowing water to flow over the blades rather than striking it individually. The draft tube. The draft tube is employed to address the pressure difference at the exit of the runner. As the pressure is generally lower than atmospheric pressure, the tube gradually decreases in the area to discharge water from the turbine's exit the trail race. This ensures smooth water flow and prevents direct discharge into the trail place. The draft tube. So the purpose of the draft tube are basically a tube or a shell around the shaft of the mixer, including a usual axial impeller, which allow a special or top to bottom fixed flow pattern to be set up in a fluid system. So that is for draft tube. And this is the working principle of Francis turbine. The working principle of the Francis turbine is discussed in the following lines. Water first enters the runner to the Francis turbine through guide vanes or wicket gates adjustable for flow control. The initial entry low velocity and high pressure. The passage over vanes shift the pressure to velocity, converting hydraulic energy to kinetic energy. This resultant kinetic energy drives the rotation of the turbine wheel. The water exceeding moves through the draft tube, gradually widening and submerging to generate a suction head at the runner exit. The suction head facilitates smooth transition of water into the trail race. And this is the main benefits and main disadvantage of a Francis turbine. First, for benefits, it is straightforward to control even with variable heights. The variation of its efficiency is very low over time. The corridor size is small compared to other types of turbines. It has a lower maintenance cost compared to other types of turbines. And for disadvantages, Francis turbines are designed for a specific flow. It is not the best option to use in front of significant flow variation since the performance lowers. It presents problem when working with heights than 800 meters. It has a cavitation problem, and last, the entry of dirty water with particles can cause significant problems to the turbines. That's all. Thank you.